everybody! In this challenge problem, we're going to be using the concept of potential energy as well as center of mass and some basic algebra. So let's get started!
So here is our challenge problem. Calculate the potential energy released if a 50-story building with a mass of about 2 times 10 to the power of 8 kilograms and a height of 150 meters collapses. Assume that the mass is distributed uniformly and gravity is 10 meters per second square, just for simplicity. So the first thing I'm going to do is draw the diagram. So if that is the building basically, then this would be its mass, and if we're assuming this is taken before the building collapses, then it's pretty much at rest. So now for the height, you might be saying that the height is just going to be this as the height. But if we draw the story, 150 meters might be true as the height for, say, the 50th story. So story number 50. So this might be 150 meters or something close to that. But what about for maybe the first story? The first story would probably not have a height of 150 meters. It doesn't. What about the 49th story and the second story? So I think you get the point right now. The height is not 150 meters. Instead, we would have to take the average height of the whole building. In this case, if it has 150 meters as the whole building, the average height would be 150 by 2, making it 75. So this would be around h being 75 meters. So if we assume that the mass was distributed uniformly, that means the center of mass would be at a height of 75 meters. And the potential energy, the gravitational potential energy, is always calculated from the height of the center of mass, not the height of the whole thing. So if we go and fill out our table, our mass is 2 times 10 to the power of 8 kilograms. The height, it's the height of the center of mass, and that is 75 meters. The potential energy we haven't calculated yet, and gravity is 10 meters per second squared. So if we were to solve for the potential energy now, that would be EP is equal to the mass times the height, in this case from the center of mass, times the gravity. So that means that potential energy is equal to 2 times 10 to the power of 8 times 75 times 10, which is equal to 1.5 times 10 to the power of 11 joules. So just to give a sense of perspective here, the approximate food energy consumed by an average human in an 80-year lifetime is 2.4 times 10 to the power of 11 joules. The maximum fuel energy of an Airbus A330 is 3.4 times 10 to the power of 12 joules, and the orbital kinetic energy of the ISS, the International Space Station, is 1.2 times 10 to the power of 13 joules.
Thanks for watching. If you liked this video, please drop a like and subscribe, and I'll see you in the next one.